Hi, welcome, and thank you for joining in. A quick tip before you go any further. All programs discussed in the videos have links in the description below. You can click and look at them and understand them better. And also don't forget to subscribe. We are going to start with operators. We look at arithmetic operators, assignment operators, augmented assignment operators, comparison and identity operators, logical operators, chained operators, binary operators, and operators precedence. We start with arithmetic operators where we are going to look at addition, subtraction, multiplication, division, modulus, which is basically the remainder after you divide one number by another, exponentiation, which is one number raised to power another, floor division, which is always going to give us the quotient as an integer. We look at an example of arithmetic operators where we've taken two variables a and b. A is 7, b is 5. We find their sum, which is 12. We find their product, which is 35. We find the difference, which is 2. We divide a by b. We get the quotient 1.4. We do floor division and it removes the decimal part of it and we get 1. Use the exponential operators for b raised to power a and we get 78,125. And we divide a by b and the remainder, that is 2, we get by using the operator modulo. We come to assignment operators. Assignment is an important part of programming. And we have the operator equal to, which basically says that assign this value to this variable. We also have plus equal to, where we're going to add a value to the variable and reassign it to the same variable. Similarly, for minus equal to, multiplication equal to, division equal to, or even floor division equal to, and even exponential equal to. In all these, we are going to perform that particular arithmetic operation and then reassign that value to the same variable. There are two ways to do this. One is the normal assignment and the other one is called the augmented assignment, which is given here. Now in augmented assignment, there's a bit of difference from the normal assignment in the way it is handled in the memory. This is done in place. That means the memory usage is a little less than what it is in assignment. For assignment operators and augmented assignment operators, we will start with the variable a, which has value 10. We increment it using the normal assignment statement. A is equal to a plus 5. That is, we add 5 to a and reassign it to the variable a itself. We get an output 15. We can do this using the augmented assignment statement, that is a plus is equal to 5. This will add another 5 to a and reassign the value when we print it. We have b is equal to 20. B minus is equal to 10 will give us an output of 10. We use c is equal to 50 and we multiply it by 2. We get the output 100. We divide the c by 5. We get the output 20.0. We again divide this using the augmented division sign. We take z is equal to 30 and we divide 30 by 4, which is the last value of c, that is 4.0. And then we use the modulo operator here in augmented assignment. This will give us the output 2. We now take two variables, num1 and num2. So we divide num1 by num2 and reassign it to num1. Num1 will now have this long value of 6.666. And then we divide this num1 again by num2 using floor division. We now will get a neat output 2.0 because it will ignore everything after the decimal to just give us this value. The next operators are comparison operators where we check whether the two values are equal, not equal, if one is greater than the other, or is one less than the other, greater than equal to another, or less than equal to another. Now, in this case, the output is always going to be a Boolean, either true or false. Identity operators are similar to comparison operators in that we do check whether the two variables are the same. However, in this case, we're going to also check whether they are the same object. And we look at this in an example. We look at comparison operators and identity operators using three variables here. A is 15, B is 10, C is 10.0. And we check whether B equal to A using the comparison operator equal to. The output is false. We then check is B not equal to A, and it gives us an output true. If we check is B equal to C using the equal to operator, we get true because B is 10 and C is 10.0, so the value is same. However, when we use the identity operator, which checks whether both are the same data type as well, this will give us false. So B is not identical to C. If we check if B is less than A, it gives us true. If we check A greater than 15, it gives us false. However, if we check A greater than equal to 15, it gives us true. Now we are going to use X, which is a string and has value 10. We use a variable Y, which has value 10.0, and Z, which has the value which is returned from dividing 20 by 2. We check is X equal to Y, and the output is false. We check is Y identical to Z, and the output is true because even though 20 and 2 are integers, after division, Z will become a float with the value 10.0. So both Y and Z will have the same value and the same data type. Another set of operators are logical operators and, or, and not. The AND operator will return true if both the statements are true, or returns true if one of the statements is true, and not will reverse the result. Now we look at this with examples. We look at logical operators and, or, and not. We use two variables, age, which accepts a number as age from the user, n accepts a string for the nationality. We use the AND operator to check what the user has input. If the age is greater than equal to 18 and n is equal to Indian, the output should be true, otherwise the output will be false. Here we have input age 18 and the nationality Russian, so the output is going to be false. Now, if we use the NOT operator with the AND operator, it's going to give us the output true because it reverses the output of the AND. Using the OR operator, if we check age greater than equal to 18 or n equal to Indian, the output will be true. However, if we use NOT operator, the same thing will be reversed and now it will give us output false. We also take three variables A, B, and C, give them values 20, 10, and 17. Now we're going to use some chained operators, A greater than B and less than C. This actually checks whether A is greater than B and B is less than C. Now both these things are true, hence the output is true. In a chained operator, we can give the comparison operators together and the AND operator will be implemented within the two conditions. We'll take a quick look at membership operators. We will, however, look at this again in the coming chapters. In is a membership operator that returns true if a sequence with a specified value is present in the object, and not in will return true if the sequence with the specified value is not present in the object. We'll see a lot of usage of membership operators when we do lists, tuples, and dictionaries. Binary operators, as the name suggests, work with the binary numbering system of bits. We're going to take a look at some of these operators: AND, OR, XOR, and NOT. In the bitwise AND operator, we have to compare each bit of the two numbers, and then according to the rules of AND, we get an output. So if we compare two binary numbers, we compare each bit, and if the two bits are 0, the output will be 0. If one of them is 0, the other is 1, it will still give us an output 0. If both the bits are 1, the output will be 1. So here we look at two variables x and y. Both have binary values. The first one is 1, 0, 0. The second one is 1, 1, 0. So comparing each bit, we get an output 1, 0, 0. In the bitwise OR operator, we check each bit of both the variables and compare them using the OR operator rules. That is, if both are 0, the output is 0. If one of them is 1, the output is 1. If both are 1, the output is again 1. In this example, we have two variables x and y. X is 1, 0, 0. Y was 1, 0, but we add 0 to the most significant bit so that the number of bits in the two are the same. And then we compare each bit. So according to the rules, the output will be 1, 1, 0. Now we look at the bitwise XOR operator, where we will compare the bits, and if the bits are same, the output is 0. If the two bits compared are opposite, then the output is 1. Let us look at the binary operators AND, OR, and XOR. With an example, we start with variable x, to which we've given a binary value 1, 0, 0. Y has the binary value 1, 1, 0. And we use the bitwise or binary operator and store the value in Z. When we output this using the function bin, the binary value it will output is 1, 0, 0. Similarly, we use bin 1, which is 1, 1, 0. Bin 2 is 1, 0, but we've added a 0 to the most significant bit so that we have exactly same number of bits in both the numbers. So we compare these using the OR operator, and the output will be 1, 1, 0. We take two more variables, m, which is 1, 1, 0, n, which is 1, 1, but we add 0 to its most significant bit, so that the number of bits in both the numbers is exactly the same. We use the XOR operator and we get the output P, which we use binary function to output 1, 0, 1. In any programming language, it's important to know the precedence of operators. In Python, the precedence is parenthesis on the highest priority, exponent comes next, division, floor division, multiplication, and modulo come next. Then there's addition and subtraction. The bitwise and XOR OR operators are next. Then we have comparison operators, followed by identity operators, the Boolean, not, and OR. To look at operator precedence in Python, we take this statement print 10 plus 3 multiplied by 2 and floor division by 5. Now, since multiplication and floor division have the same priority, it will start from the left by multiplying 3 by 2 and then dividing it by 5, just giving the integer as answer. And then that will be added to 10. So the output is 11. However, if we put 2 floor divided by 5 in a bracket, the parentheses start getting the higher priority. So this will output 0, which then multiplied by 3 will give us a 0. The output will be 10. Now take three variables, color, size, and count. Color is red, size is medium, and count is an integer 100. We are going to print the output while checking size equal to medium or color equal to blue and count less than 100. Now, since count is not less than 100 and blue is not the color, it should give us false. However, it gives us true. That is because this will take place first and the output will be false. The OR will come later and will compare it with size is equal to medium, which is true. So the output will be true. If we put the OR operator in the bracket and then use the AND, this will give us true, but with AND, count less than 100 is false, hence the output will be false. Before you go, don't forget to click on the links in the description below. They'll help you understand the programs better. Also subscribe to the channel, click on the bell icon so that every time I upload a new video, you'll know of it. See you soon. Bye-bye.